This is the part 2 of the video. In part 1, we build the bound graph model for the car seat mechanical system as shown in this sketch. And also we connected them and explained how to connect the power bonds and also how to rename the elements if we want to. Now I'm going to apply some values, numerical values to the elements, and also I would like to demonstrate how to use the model bound graph model for simulation and eventually running some runs to show the variation of some quantities, some variables that we choose to see their variations. To save some time in the video, I will do this for maybe a couple of elements here. I will do it for 1C and maybe for one of the SEs, and then I will use a similar model, exactly the same, which I have prepared to save some time in the video time that we are going to demonstrate the model. Okay, so how do you do it? As I mentioned in part 1, actually you can click on the variable icon, the parameters actually, and then for each one you can assign, for example, mass 2, which is the weight of a mass of a typical person, let's say 80 kilogram, and the seat is, let's say, 27 kilogram, and so on. You can do it this way, or actually you can go to each one of these elements and assign the corresponding values. For mass 2, which is shown here, I2, I double click on it, and as you see here, a small equation model shows up, and these are basically the equation or the model that actually runs in the background when you hit a run icon and then you want to run the simulation. So by default, this is I would like to change it to M2 to be compatible, and we have to make sure that you change it in the equation. So what we have here is the parameters, the mass, and the mass we say 80, and we can assign the units for the components here is kilogram into curly brackets. And what is the equation here? Equation is the state, which is the momentum integral of the effort, the force, and the flow, which is the momentum divided by mass. You can add comments here if you like, which is the velocity of M2, and so on. Momentum of M2, and so on. So if you like, you can add or not mass of driver, and so on. Okay, so always check for completeness, make sure there is no error. Sometimes you may miss a semicolon or something like that, so there is no error in the equation model. Okay, so for the parameters, I have the the B1, B2, and the rest of them I assigned the values. I use the stiffness definition for the springs, and also the corresponding masses and dampers. So this is good. Apply. Okay. So we have everything good. If you want to double check, or if you want to quickly change something, again you can double click here and change it, change the value you want to change. Okay, so at this point we have everything ready. Always good practice to check the model, and then we are ready to run the model. For running, you can click on the Start Simulator model, or basically go to Model and say Start Simulator. Either way is fine, and then you get the simulator screen. Now, here I have added some graphs here, and I will show in future videos how to add graphs. So here is the momentum for the driver, the spring displacement under the seat, and this is my signal. So this is the signal that I mentioned. So if you go back to the model and click on the step function, so you say I gave it 1 amplitude, start time 1, so you can give it a different value, maybe start time 5, for example. At 5 seconds, it goes over a step, and then you can run the model again. So if you come here and run it, then you see that the step function starts at 5 seconds after the start of the motion, and you see the displacement and also the driver momentum. For example, if you want the force of the spring, so you come here. So let's say this is the spring. Let me open this graph and add a curve here. So this is the seat spring. So the seat spring is actually K1. So when we are in K1, then I need to choose K1 here, and because I need the force, then the force would be this guy here, which is the P. P stands for port, and E is the effort. So that is good. Let's give it another, maybe different line style. So keep the same color, and then say OK, and then you can bring back the video, and then you see that this is the force, and so on and so forth. So if you want to change it, or if you want to add any curve, you can add it here, and you can actually come here and add another plot, and then say, okay, let's see what is the damper, for example. So this would be the damper 1 force, for example, and double click on it and choose the corresponding. So damper 1 force is what? Damper 1 force is under the seat, and damper 1 force is B1, and the force is PE, and then you say OK, and maybe give it a different line style, and then that's good, and then run it again. So this is the damper force, which you see here in this graph. So you can play with this easily, and then this is a very powerful tool to run your analysis and do your design. So this concludes part 2 of this example. This is introduction, and in future example we will go after doing many of these models, and in each one I will maybe repeat previous tools that I use for that specific model at the time, or actually using new features available, or new facilities available into anything. Thank you.